Welcome back. This is where we stopped in the last video. The number of life and score are exhibited on the screen. Man can get entangled with the coronavirus. If he gets infected, he will be alerted. He can run for medical aid, recover and return for the fight of another life. But this second life is his last. Before proceeding further with the game plot, I want to set up a frame rate for the game. If we do not control the rate of frames, the visual effect of a program on two computers which run at different speeds will be totally different. The number and size of the objects that are loaded during a program can also influence the visual effect. The time module of Pygame makes available a series of utilities. We have already imported the module in the environment segment. Let's see how to implement a frame rate for the game. We created a variable FPS and stored the targeted frame rate of 30 in it. We also created an object clock and stored a Pygame method pygame.time.clock in it. In the while loop, we placed a Pygame function clock.tick with the variable FPS as the argument. This will control the process which run too fast. But we cannot arbitrarily increase the frame rate. It has a limitation in the processor speed of the computer, number and size of objects getting loaded, efficiency of programming and so on. So we must take these aspects into consideration while giving higher frame rate. We will use the getFPS function in Pygame to calculate FPS and try to understand how this works. I will first show how FPS works on a skeletal program. Here in the game loop, there is a screen fill statement followed by a background image load and a man image load. The loop also responds to a quit event. We will now set up a frame rate for this program, which has minimum objects and functions. We have created an object clock by storing the result of the Pygame method pygame.time.clock. We have stored the desired frame rate of 80 frames per second in the variable FPS. Within the loop, we have used the Pygame method clock.tick with FPS as the argument to regulate the frame rate. We have set the frame rate at 80 per second, but we want to find out the actual frame rate of this program. We have created a function FPS to calculate the actual frame rate and display it on the screen. First, we will create a font. You can see the code here. We have set the font sys font Arial with size 80 into font. Having created the font, we will now create the function to get the frame rate and display it on the screen. Have a look at the code of this function. We use the clock.getFPS method to obtain frame rate per second, converted it to integer and saved it as a string in the variable fr. Using the font created, we have rendered the frame per second to the variable FRT. We then placed it on the screen using screenBlit. We call this function from within the loop, which gives us the display of FPS on our screen. We will save the program, run it and see how this works. It almost gives us the frame rate per second of 80. But we must bear it in mind that we are working within the limits of processor speed, which can be impacted by size and number of objects getting loaded and the processes run. Let us see an example. I will now add a print statement within the loop below the line calling the function FPS and see how it impacts the frames per second. I just added the print clock statement. This statement is the only addition to the code. Let us run it and see whether the frame rate will be affected. Though we maintained a frame rate of 80 in our program, the frame rate per second has come down from the 78-79 we had in the program before amending it. Now it is showing 49, 47, 49, 50, that range. I just wanted to emphasize that redundancies must be avoided and efficiency of coding improved for optimum result. Let us proceed further with the game. The revitalized warrior, now at life 2 with a green mask, returns to fight. This time when the mask turns red completely, it is game over. We have to immobilize the warrior and his gun. We have to declare that it is game over. For this, we will create a game over function and make changes in the first aid collision segment in the game loop. Have a look at the code of the game over function I just created. Using the font 1 we created early, we will render 2 lines of text to overtext and overtext1 and split these lines on the screen and display it. I have stored logo of our channel as gkbuddy.jpg in the game directory. You can see the code here. gkbuddy.jpg has been loaded to the variable gkbuddy. In the variable overtext, we have saved the declaration game over. You only live twice. And in overtext1, dedicated to the Corona warriors across the world, has been saved. These texts we will split on the screen through the game over function, and below it we will also split the your gkbuddy logo on the screen. Now we will call the game over function at first aid collision segment. We'll put one condition: if life value equals 2 and health equals 0, it's game over. Here we are calling this function. Now we will save it and run it and see how it works. Game over is declared and the other text and logo also appear. But we have one problem. Even now, after declaration of game over, our warrior can move and he is able to fire the gun. We must immobilize him and his gun. Let's do it now. Now the life value of our warrior is 2 and his health index is 0. If this condition is true, we will add one code here. Bullet state, we will change it to dead. Presently the bullet has 2 conditions, ready and fire. We will set a new condition dead, and the other functions will not be able to recognize the new condition dead, and the gun will be immobilized. Still the man can move. So to immobilize man, the man change value will be made 0. Now it should work. Let us now save it and run it and see once again. Now the game over text and the logo are displayed. Now we'll see whether man can move now. He has been immobilized. He cannot fire his gun also. That almost finishes the game, but a few more things are there to be taken care of. The number of viruses released are preset and gradually they go off screen. For example, right now we have set the number of viruses to 20. Suppose a smart gamer dodges the viruses and keeps his life intact. Then there will be a time when the warrior is there alone on the screen with no viruses to shoot at. We will take care of this and other small issues in the next video. Hope you enjoyed the video. If you liked it, please subscribe to our channel. Please use the comment section to communicate with us. We would very much appreciate your feedback. Thank you very much for watching. See you soon with the next video.